Okay, welcome to more equations and rearranging of formula. We're doing this step by step, and they're kind of easy, but they're gradually getting a bit more tricky. This one can be done in two ways, or there's two paths to follow. The one is probably easier than the other, but it doesn't really make such a big difference. So sometimes you can see the alternative quicker route, and sometimes you can't. But let's I'm going to take let's say I'm going to take the difficult route first. So the difficult route would be looking at the fraction and saying, I want to get the fractions out of the way as soon as possible. That's the first thing. And sometimes this route is the best route, especially if it's not as easy as a 3 and a 1, then we can, multiplying or getting the fractions out of the way sometimes is easier. And in order to do that, I'm thinking about this x being divided by 2. Now, previously you would have heard me, we want to get all the x's on one side and all the numbers on the other side, and that's kind of the second route that I'll explain later. But for this one, let's just say I really hate fractions and I want to get fractions out of the way. This x is being divided by 2, so I have to find the opposite. So I'm going to have to multiply this x by 2, and well, maybe I'll write it here. 2 over 1 makes it a little bit easier for you to understand, and they would cancel out and I'd be left with x. But every single term has to be multiplied by 2 now. It's not just one side and the other side. It's every single term. So I can't just multiply this side by 2. I have to actually multiply this negative 3 by 2 as well. So x times 2... So everything should be multiplied by 2, and that might be a little confusing because we said we only do on one side what we do on the other side. But if we have multiple terms, every single of those terms has to be doubled in this case. So minus 3 times 2 is going to be minus 6, and minus 1 times 2 is going to be minus 2. And now I'm going to add a 6 on both sides. And then I'll be left with x is negative 2 plus 6 is 4. The other route that I could have followed is I could have said, well, x divided by 2 is equal to negative 1, and I could have added the plus 3 first, and then add the plus 3, right? So add the plus 3 on both sides, the negative 3 would have cancelled out, and then I would have x over 2 is equal to, what's this, 2. And now I can multiply by 2 on both sides, and I would get x is 4. So you see, both got to the same place. One is not better, one is not worse. It just depends on the type of the equation. In this case, I think this path would be easier, but there might be some instances where this path is easier. But it's important to remember that when you multiply, every single term has to be multiplied. Even if I had a minus 2, minus 3 here at the end, every single term should be multiplied with 2. So that's a bit of a catch. Okay, let's take a look at next example. What do we have here? Let's do 2x divided by 3 minus 6 is x. Again, two paths to follow. We can multiply by 3 because we want to get the fraction away, or we can just kind of rearrange everything around. Now, let's do both methods, then we know it's covered. It doesn't really matter what we do first. But this 2x, or this x is kind of in a relationship with the 2 and the 3. So eventually we'll want to get all the x's alone on this side. So this x will eventually come towards this side, but first we want to get rid of the fraction because that's just, we don't have to, but we want to in this case. So I'm going to multiply by 3 here. So I know this and this is going to cancel out, so I'll have a 2x. I'll have to multiply this by 3. Oh, why did I write a plus? I have to multiply this by 3. Last time I checked, 6 times 3 was 18. And every single term, not just the one on the other side, every single term has to be multiplied when I do kind of the multiplication thing or division thing. And in this case, this becomes 3x. But now I want to get this minus 18 away, so I'm going to add 18 on both sides. and that would leave me with 2x is 3x plus 18. And now I'm gonna subtract. You don't have to take it, you don't have to, take such a long route. Later you'll be very quick and you'll just say, okay, well, I have a 3x on this side, I'll take it to that side, so it's going to be 2x minus 3x, and I have a minus 18, so that's going to be a plus 18. Another option would have been to just know that there are more x's on this side, so taking the 2 over would have given you a positive x value on this side, because you would have had 3x minus 2x is equal to negative 18. But now we're going to have 2 minus 3, so we're going to have minus x is 18. But I don't want to know what minus x is, I want to know what x is. So I'm going to divide both sides by minus 1, or I can just kind of swap them around, right? So if I take the minus x to this side, it becomes a plus x, and the 18 to that side becomes a negative 18. But yeah, we can just divide by negative 1 as well, and we'll end up with x being negative 18. Okay, let's take a look at if we rearranged kind of the terms first. So I would have had 2x over 3, and I would have subtracted an x on both sides, so it would have been minus x, and there would have been a plus 6 on both sides, and that would have been plus 6. And now I could have multiplied. I couldn't do anything with this. I have to, if I wanted to add this, I'd have to get the same, denominator, etc. But because it's a equation, I can just multiply by 3. So I'll have 2x minus this has to be multiplied by 3, and this has to be multiplied by 3. And then we have the same thing. Minus x is 18, and x would be then negative 18. Okay, so both ways work. This one looked a bit, maybe it just looks quicker because I kind of did these steps kind of just quickly. And the more you do these examples, the quicker they become. But I would advise not doing too much at the same time, because then you can easily make sign mistakes, like having a plus or not a plus or minus or something. Okay, let's do one more. That is... let's see what color. We'll make it red because it's a bit interesting. So x plus 2 all divided by 4 is 2x minus 2. Again, I'm not going to do both roots this time. I just want to get the fractions gone. So I'm going to multiply by 4, but not just one side. Every single term has to be multiplied by 4. And I'd be left with x plus 2 is equal to 2 times 4 is 8x, and that would be minus 8. And now I can see there's more 8s here, and these 8s are positive. In math, we kind of like to use positive, so I'm going to keep the 8x here. I'm going to subtract an x on both sides, so this is going to become minus x. Here I have a plus 2, I'm going to keep that 2 here, but it's a minus 8 here, so I'm adding 8 on both sides. The 2 is a plus 2, right? So now I'm left with 8x minus 1x is 7x, and that would be equal to 10. And to get this away, I'll have to divide by 7 on both sides, and now I have x is 10 over 7. Can write it as 3 and 3 sevens. Oh no, sorry, 1 and not 3. 1 and 3 sevens if I wanted to. 1 and 3 over 7. Doesn't really matter, but in this case you can see that brute forcing or thinking of numbers wouldn't have really worked out for us. We got this mixed number thing, so following the root and just thinking what is being done with the x and just undoing it. So we undid by it was being divided, so we added, and then here I basically just added 8 on both sides and subtracted an x on both sides, etc. Okay,